Hello, good morning. Here, let me turn on my camera. Let's see. Good morning. Welcome to today's webinar. We're getting ready to get started. I think folks will start coming in. We'll get started. If folks join late, they'll miss the opening bit. Just some basic stuff to cover before we get started. By joining this webinar, you agree to the terms of the OnGo Alliance's privacy policy located in the event description, and we will be recording this session and we'll be distributing it, putting it online so folks can get access to it. If you have any questions, please use the chat function in the GoToWebinar. You should be able to see a questions section, and we'll try to address any questions you have in real time, and general questions we'll address afterwards. This ends on a frequently asked questions area. So if I don't get to your question immediately, it's hopefully because I'm getting to it at the end in that fact section. But anything we don't get to during the course of this webinar, we will follow up with by email. And if you have any additional questions, you can reach out to me at the SHNI at OnGoAlliance.org or my email at .fashan@OnGoAlliance.org. And by way of introduction, my name is Ed Fashan, and I am the Identifier Manager and I think Ecosystem Program Manager for the OnGo Alliance. I'm one of the staff for the organization. On the topics we're going to be covering today is we'll do a quick overview of what is CBRS and OnGo, and then we'll look at the PLMN ID and LTE and the CBRS Shared HNI, how we use that within OnGo. And then we'll look at some of the impacts of that, how we have to manage certain identifiers. I'll also be talking a little bit about these identifiers in 5G and how you actually go about the process of getting identifiers, and then closing on the frequently asked questions. So please, if you have any questions, use the question function and we'll try and get to them. Okay, so what is CBRS? Hopefully you're familiar, but in case not, I'll give you the quick rundown. The CBRS band is 150 megahertz at 3550 to 3700 megahertz. That has been opened up for use by the FCC. These were previously, it was reserved for military radars, mostly ship-based radars, and then satellite ground stations and some of the wireless internet service providers used this. But the FCC opened this up a year or so ago for other uses. And they auctioned off access to the band in 10 megahertz channels and blocks. And they did this a little over a year ago on a per county basis. And these are called priority access licenses. And up to 7 channels were sold per county in this auction. And they have the second level of access. The incumbent systems have the ultimate access. The priority access licenses get their second tier, and below that, any unused spectra in a location can be opened up to anyone, and it's called general authorized access. And access to the band is actually controlled in a new system, a dynamic system, controlled by what's called the SAS, or the Shared Access System. And it monitors the incumbents to see what their activities are. And priority access license holders, pardon me, the PAL holders can request access to the band, and they're given protected channels. And then anything that's not being used is open to the generally authorized users, the GAA users. And so this is a significant innovation. This is a lot of frequency that's opened up for anybody basically to get access to. And the OnGo Alliance, we are devoted towards deployment of 3GPP based technologies in the CBRS band, so LTE, 5G, and R. And that's what we work to promote and support. So with that as a quick overview of what LTE, or of what the CBRS band and on the OnGo Alliance is, we're going to look a little bit at how LTE uses identifiers. The 3GPP defined how these LTE networks work, and the way they identify themselves is by constantly broadcasting an identifier of their network. It's called the PLMN ID, the Public Land Mobile Network Identifier. And devices have on their SIM cards typically a list of PLMN IDs that they recognize as their home network. And so they look for networks that are broadcasting a known PLMN ID, and if it sees one it recognizes, it tries to connect. And the way that devices identify themselves is through a number called the International Mobile Subscriber Identifier, the IMSI, and that's how they identify themselves to the network. And that's a really gross oversimplification. There's all sorts of cryptography and encryption and stuff that goes on as part of that. But basically, they use their IMSI to help identify themselves. So this the public land mobile network identifier, the PLMN ID, sometimes in certain contexts you refer to it as the home network identifier, the HNI. It's a 6-digit number, and it consists of a 3-digit country code, mobile country code, and then a 3-digit mobile network code. Now the country codes are managed by the ITU, while the network codes are delegated to various national regional administrators for each mobile country code. And in the US, it's iConnective or ATIS, the US MC administrator. It's part of their role and duties is to assign mobile network codes. And then again, this PLMN ID is what's broadcast by the base stations to identify them. And there is a problem with this system. That is, it was originally designed to support large networks, which is why it's only 6 digits long. There's a limited available number space. And in the case of the United States, for example, we've had to get several mobile country codes because we've run out of the mobile network codes. And many operators actually end up having multiple PLMN IDs. And this system is really not practical for use by small private networks because there just aren't enough available numbers. With OnGo, with this new spectrum and this new access system, it's now practical to deploy private and small LTE networks. So you can put one in your home, you can put one in your office buildings. But if you do that, we're just going to run out of these PLMN IDs really fast. And so we need some way to resolve this issue to make sure we don't run out of PLMN IDs. And the solution to this was come up for CBRS was to get a single PLMN ID for the CBRS band. And we call it the CBRS Shared HNI. It is 315010 is the identifier. 315 is the country code. 010 is the network code. And networks that operate in the CBRS band can use this CBRS Shared HNI to identify themselves. But since you have multiple networks identifying themselves with the same PLMN ID, we need to have a new identifier to uniquely identify them. Those networks that are using this shared PLMN ID, and that is we call the CBRS network ID, the CBRS NID. And so OnGo networks use the CBRS NID to identify themselves when they are using the CBRS Shared HNI. And fortunately for us, the 3GPP defined a mechanism that does everything we need it to do and support the CBRS NID, and we call that the closed subscriber group is the mechanism. It was defined by the 3GPP that the eNodeBs can broadcast, in addition to the PLMN ID, they can broadcast a closed subscriber group ID, and devices will only connect to that cell, that part of the network, if both the PLMN ID match and the CSG ID matches. So what we do is we just use that CSG ID mechanism and we broadcast the CBRS NID in that CSG ID field. The upshot of this is that we have no changes needed to the 3GPP specifications. It does everything we need to do, roaming, handoff, everything is handled within the specs. It's great. So we didn't have to change the specifications in any way to support this shared HNI. But there's one little problem with it. It's that few user devices, few handsets, UEs, an LTE term, very few of them support the CSG mechanism. In general, the device makers and chipset makers, they implemented it, but the network operators very rarely use it currently, the MNOs. I'm aware of only like one location where this gets used. And because this mechanism can have a small impact on idle power consumption, the device makers typically have removed it from their software builds, from their primary software builds. Fortunately for us, the impact of a device doesn't support the CSG-ID mechanism is very minimal. The user device will just try and connect to any network using the OnGo, the shared HNI, regardless of the CBRS NID being broadcast. But authentication will fail and it will try the next network. The impact of this, ultimately from the user's perspective, is a slightly longer network acquisition time. But as device makers, if they start re-implementing, reactivating the CSG-ID mechanism in their devices, that will make it so that devices will be able to connect to an OnGo network a little more quickly. So that's what the CBRS NID is and why we need something like this. Why do we need this shared HNI, and why do we need a CBRS NID? But there's another wrinkle that comes out of using this shared PLMN ID, and that is that LTE, the 3GPP specifications, they have a bunch of identifiers in them that need to be globally unique, that they can't be repeated. And the standard way they handled this within the specifications was to incorporate the PLMN ID into these identifiers. And that way it was up to the individual network operators to make sure they didn't accidentally reuse the same IDs. And if they made a mistake, it only affected them because other networks are using a different PLMN ID, so they don't have to, it won't impact them. And this shows up in a couple of places. The MC, that identifier the phone uses to identify itself, what's on the SIM card, that incorporates the PLMN ID. And then a bunch of elements, mostly associated with mobility within LTE, use this PLMN ID for global uniqueness. The first is the GUMI, the Globally Unique Mobility Management Entity Identifier. And this identifies a component of the network called the MME, the Mobility Management Entity. And that's what's responsible for routing data to and from individual devices as they roam around the network. There's also something called the GUTI, the Globally Unique Temporary Identifier, that's assigned by the network to a device to temporarily identify it, kind of in the name. And then there's also something called the ECGI, the Ultra-Cell Global Identifier. And this is used to individually identify cells in the network. And it's used by the self-optimization systems within LTE, and it also shows up in like some of the location-based stuff like E911 services, and it just uniquely identifies each cell. And then lastly is the tracking area ID. This is, it identifies segments of the network. Networks in LTE can be divided into smaller subnetworks tracking areas, and then the network monitors devices as they move around the network by keeping track of which tracking area that they're in. So those are the identifiers that are used. Now the problem is, if you have multiple people using this CBRS Shared HNI, their different network operators could just accidentally use the same identifier. And this can cause collisions, is the term for it. And these can cause issues. If you accidentally use the same MC twice, this will cause authentication failures. If the GUMI, GUTI, or tracking area, if you have collisions there, you'll start having mobility and connectivity failures. You'll lose connections, you'll lose track of the devices, it moves through the network, handoffs will fail. And some of the failure modes are kind of ugly, like a tracking area collision can cause a 12-hour denial of service based off the errors as they're defined in LTE. And the ECGI collisions, you'll have your SON, your self-optimizing network systems will fail, so you get potentially increased interference between cells, and it reduces the accuracy of things like location services for like E911. So we need to prevent collisions in the OnGo context. If you're using the CBRS SHNI, we need to make sure you don't get collisions. And so the way we do that is we manage components of these identifiers to ensure that they're globally unique. And each of these identifiers has multiple components, and we manage specific elements of it. And therefore, we need to manage the MMEGI, the eNodeB ID, and the tracking area code. And so what we do, if you are using the CBRS Shared HNI, we will tell you which identifiers to use for these values and make sure that there won't be collisions. So this is the best way to prevent these collisions when you're using this shared HNI. So we manage these identifiers to make sure that you don't get collisions. And we manage the CBRS NID, we assign that to you. We assign the MMEGI, the MEMEGI, the Mobility Management Entity Group ID, and also the eNode B ID, we assign those as well. Now this is open to anyone, not just like members of the Alliance. Anyone can get these identifiers and you can get as many as you need. We charge a small administration fee when you initially get it on an annual renewal basis, just to make sure that nobody tries to squat on a significant percentage of our number space and to cover the administrative costs. So that's the basic solution, is we manage these 3 identifiers, and that's the way we prevent collisions. But there's 2 of the identifiers I've mentioned that we don't manage. We don't manage the MCs, and we don't manage the tracking area indicators. And we actually get this resolved in a different way for these components. The MCs are actually technically managed by the US MC administrator. And so what we've done is we have taken the component of the MC that doesn't include the PLMN ID. It's called MSIN, the Mobile Subscriber Identifier Number. It's a 9-digit number. And we've divided it into a 4-digit MC block number and a 5-digit UIN. And so if you need to issue SIM cards, if you need, which you'll need if you're deploying a private network, you go to the US MC administrator and request an MC block number for them. And with that MC block number, you'll be able to issue up to 100,000 SIMs. If you need more than that, you can always request an additional MC block number. And if we run out of IBNs, we can go and get a new shared HNI if we run out on those. Now that's the MC. You get it's the same basic idea. Is they manage a component. It's just the USMC administrator, for various regulatory reasons, is responsible for assigning those IBNs. Now the tracking area codes are a little different. We don't actually manage these. What we do is we let you use your IBN, your MC block number, to generate some tracking area codes. And you just use your IBN as your first tracking area code, and then you add 10,000 to it, or 20 or 30 or 40 to get additional tracking area codes. So for each IBN you essentially get 6 tracking area codes. Now this is just a recommendation of the specification, but this is really what you want to do because collisions are bad. So we don't necessarily assign individual tracking area codes. That's something you get for free when you get an MC block number. Now there are conditions where a network will want to have lots of tracking areas. OnGo networks, if you are deploying that has like multiple office buildings or multiple campuses, you might want to assign a unique tracking area code to each of those islands of coverage. And if you have a bunch, it would be inefficient to say just go get a bunch of IBNs. So we actually have a pool of managed tracking area codes that you can use. It's about 5,000 of these codes that are sitting up at the upper end of the number space that won't get addressed or ever get used using the MC block number mechanism. And if you need any of those, we don't actually charge for those. Just email me at shni@ongoalliance.org, and I'll give you any tracking area codes you need if you need more than those 6. So putting this all together, there are a couple of different identifiers. Again, there's this MC block number. There is that you get from the USMC administrator, and you use that to issue your SIMs and also generate half a dozen tags. You get the CBRS NID network identifier from us, along with the MMEGI and eNode B IDs from the OnGo Alliance. And if you need an additional tracking area codes, we will also assign those to you. Now that's covering LTE. Take a brief moment here to talk about 5G. So, but I see that we have a question. The question is, are there scenarios where you don't need identifiers and you won't face the issue of collisions? Yes, there are situations. I'll cover that at the end when there are cases where you don't need identifiers, and I'll cover that here at the end. So identifiers in 5G, how does this work if you're doing a 5G network? There's a couple of things to consider, but the nice thing is for release 16, all you need is the CBRS NID for 5G. Release 16, the 3GPP very kindly added a feature that's designed to support the kind of deployments we're doing here, where you're using a shared HNI, a shared element ID. The 3GPP calls these standalone non-public networks SNPNs and defined an SNPN NID and a couple of different ways they can be assigned. And in OnGo, we recommend you use the CBRS NID as your SNPN. The bit length's a little different, so you just pad some extra zeros. But you use the CBRS Shared HNI just like you do in LTE, and all you need to use is the CBRS NID reported as your SNPN NID, and everything's taken care of. It handles everything. There's no need to handle additional identifiers or management. It's great. They added everything we needed here, and roaming and all that stuff will work without problem. That's release 16, though. If you're looking to do release 15 of 5G, there's something in the works right now. We're working on it now in our specs, adding support for release 15 networks where you're using the CBRS Shared HNI. The solution's going to be very similar to how LTE does it. We'll use managed identifiers to prevent collisions. We'll be managing basically the same identifiers, but it'll have it, since in 5G and R, they've changed like the names and the bit lengths, but the functionality is still the same. There'll be an equivalent of the MMEGI, and it's for the, I can't remember the name of the network function off the top of my head, but it'll be basically the same thing we're doing in LTE, just slightly different names and bit lengths. So that's the overview of how and why we or sort of the why we have these identifiers managed. Why are we doing this? The how you do it, it's really very simple. You can get identifiers from us on our webpage. We have a web store up on the OnGoAlliance.org webpage. It's on the Deploy OnGo section on that landing page. You'll see a link to purchase OnGo Identifiers, and you just purchase them there. You purchase the identifiers, it alerts me, and I allocate some identifiers, and I send the identifiers you've been assigned, I send them to you. And if you're trying to get an MC block number, pardon me, the IBNs, you get those from the US MC Administrator, and they have them on their website. It's Form G. The link is here direct on the page, but you can find it if you go up to the forms this header. It's listed as Form G is the one that you want to use. I'm just going to pause here for a moment. Will the recorded webinar be made available? Yes, and I believe we will send out a link after this once we get it all processed and put together for folks to get access to it. Do we have a timeline for when the 5G SHNI will be standardized by OnGo? For release 16 was actually formally approved. That's as part of the release 4, which happened over a year ago. The release 15 stuff is in review right now. I suspect, I don't know when the actual timeline is to approve those specs, but it's going to be in the next couple of months. Another question, if I'm using one of the SaaS providers, do I need to worry about these assignments, or will they handle for me? No, they typically don't handle that for you, is my understanding, is that as the SaaSes, it's up to the network operator, and I'll talk about that a little bit more detail here in a moment. All right. Let's see. Let's go into the FAQ here. Now that we're here at the end here. Who needs to get identifiers? It's basically anyone deploying or operating a private OnGo network. Or if you're doing a neutral host network and you have a private slice, you'll need to get identifiers for your private network. That's typically who needs to get them. Who doesn't need to get identifiers? It's device makers. You don't need to have one of these at manufacturing or cert or test time. We have some IDs reserved for use in test purposes. I mean, if you're deploying a pure neutral host network, you won't need identifiers. You'll get those from the participating service providers, the networks they're using your neutral host. How many identifiers do you need? Typically, you need one CBRS NID per private network. So if you're operating multiple different private networks or supporting those, you'll need a different NID for each one of those. You typically only need one MMEGI. The MMEGI can support up to 256 individual MMEs because there's an 8-bit MME ID that's included in the GUMI. And each MME can handle a lot of devices. So if you need more than 256 MMEs, you'll need more than one MMEGI. But at that point, you're probably such a big network that you either already have, or I would recommend considering getting your own PLMN ID because you're deploying a very large network at that point. And you'll also typically need one eNode B ID per base station, or CBSD in OnGo and CBRS terminology. Some CBSDs may have multiple eNode Bs in them. And like with the MMEGI, there is an additional 8-bit component called the cell ID that is included as part of the ECGI. And you can use some of those 8 bits to identify individual eNode Bs. So you can do some reuse of the eNode B ID by taking advantage of that cell ID, but we recommend typically one eNode B per base station. When should I get identifiers? Prior to deploying your network. The sooner is the better, because the last thing you want to be is like getting ready to flip the switch and realizing you don't have the identifiers you need. So recommend doing it earlier. And to address the question we got regarding the SaaS, who is responsible for getting and renewing and maintaining these identifiers? It's whoever is operating the network. It could be the property owner or the solution provider, et cetera. That's something that needs to be included in the discussions and in your contracts with any solutions providers that you may be using. And that could be the solution provider provided, or they could say, no, the property owner should do it. That's just something you guys need to work out. We as an alliance don't really care who is the specific party that gets those networks or gets those identifiers. Can you cancel identifiers? Yes, if you discover you don't need identifiers, some of the identifiers, you can let us know and we will cancel them and return them to the basic pool. Some questions about the process. How long does it take? It typically only takes a day or two to get these identifiers assigned. You buy the identifiers, it notifies me, I send you an email with the list of the identifiers that we've assigned to you. How much does it cost? We have the list of the costs here. We do have a combo package where you get one CBRS NID, one MMEGI, and 100 eNode B's IDs, or 100 eNode B IDs at a discount. And the annual renewal fee is about half of the overall fee. Is this info confidential? Get a lot of concerns about confidentiality, and yes, we do keep this information confidential. The identifier manager, me, I only will ever share contact info or identify who owns an identifier with the permission of whoever has those identifiers. So I can aid in like debugging issues if you run into interference issues and stuff, but I only ever identify someone as owning a particular ID if when given permission by the company rep. The MC block numbers, I do know that the MC administrator, they actually post a list of the MC block numbers they've assigned. So I don't know if you can ask them to not publish it or not, but they do have a list on their website of the assigned IBNs. The only information I generally provide on a regular basis is aggregate data, like how many we've assigned. These numbers are, yeah, they're like a year old now, of what identifiers I've signed to people. That's the only thing that I really report out to the organization is how many identifiers we've handed out. If you want to know more about this topic, again, we'll be posting the link. We'll be sending out a link to the recording of this here shortly, in a couple of days. We have a private LTE deployment guide that discusses a lot of this. There's a link here. But you can also just go onto our webpage and go to the resources and search for private LTE deployment guide, and you'll find it that way. If you're a member, you can get access to our specifications. Actually, you don't have to be a member to get access to some of these, but you can look where this gets defined technically is in our 1002 spec, and it's version 4 where we added the first 5G stuff for release 16, and release 15 will be coming, I believe, in the 5G. I'm sorry, the 5.0 specs that are coming shortly. The identifier guidelines, the process and administrative stuff are defined in the 100 and 101 TR documents for the OnGo Alliance. So let's see what other questions that I may not have gotten to. Normally, it seems you need to have a SaaS contract to get an SHNI. In Form G, it says there are exceptions where authorization is not required. Yes, so to get the IBN, the USMC administrator normally requests to have some evidence that you are planning on deploying a network, and they typically what they want is a contract with the SaaS or some indication that you've contracted with the SaaS. I don't know what exceptions they have. I generally think they're not, my understanding is they're not particular about that, but you'll have to discuss that directly with the USMC administrator. Unfortunately, I don't know what those exceptions are that they have defined. Let's see what else. Is there a hard requirement for SIMs to have CBRS NID CSG IDs provisioned to match what the network is broadcasting? There's not really a hard requirement per se. The system is designed around using the CBRS NID and the CSG ID, but as it stands, since devices don't often support this mechanism, and there is no formal definition of where the CSG ID is provisioned at this time, there's some work being done in one of our specs that's in development to define how that can be stored on the SIM or the eSIM. But right now there is no formal requirement on how that gets provisioned. And as I said, most devices don't support at this time the CSG ID mechanism. So it's really, you have to just have the PLMN ID, that shared HNI on the SIM. Are there any issues with using an already authorized PLMN ID instead of the CBRS when operating in the CBRS spectrum? No, it's my understanding there are no restrictions. If you already have your own PLMN ID, you can deploy in the CBRS band. The CBRS Shared HNI is actually owned. It's reserved for any network operating in the CBRS band. But if you have your own PLMN ID and have networks being used in other frequency spectrum domains and other bands, you can use that here in the CBRS band as well. Yes, this slide set will be made available. We'll be posting it shortly internally, and I believe there will be any attendees, I think we'll send it out as well. But I'll follow up with the admins on that afterwards. So again, it noted a question, if an operator gets their own PLMN ID, do they still need identifiers? No, that if you have your own PLMN ID, everything, you have to manage your own identifiers essentially, but you don't need to come to us for any of these identifiers. Has there been any roaming interoperability been completed with existing macro LTE networks using the shared HNI plus CBRS NID? Honestly, I don't know if there have been any formal tests. I do know some of the MNOs have been doing roaming testing in and out of CBRS networks. I don't know if they're using the shared HNI in that case, though. I don't know if the CBRS network they were using was the CBRS shared HNI. I don't know at this time. It's doable. And we have elements in our specifications to help address those roaming questions. It can be done. Our specifications are designed to allow it. I don't know if it has been done at this point. I believe it has, but I can't say with absolute certainty. Again, the question regarding the MC administrator and getting the SaaS contract. Again, I don't know what their exceptions are for getting an MC block number. What their exceptions are if you don't have a SaaS contract, when they'll let you do it. I think their primary concern is they don't want to be assigning MC block numbers to people that aren't actually planning on deploying a network, and so they figure if you've gotten a SaaS contract, that means you're legitimate and you're seriously going to be deploying a network. But I don't know what their exceptions are. I will actually follow up with them on that. Let me make a quick note. to check with the MC admin and SAS exceptions. I will follow up with them and see what those exceptions may be. Let's see, in 4G, if the UE does not support CSG and the authentication fails, what would the UE access? How would the UE access the network? So this in, let me see if I can go back here a bit, where I talk about this a little bit. So what happens if your network if you don't support the CSG ID, what happens is that the device will, the handset, the UE, will see a network broadcasting its PLMN ID. And so it will try and connect. And when it gets to the point where it tries to authenticate with the network, that authentication, if it's the wrong network, the network will not recognize the MC and will say, okay, you cannot connect to this network. And so the UE connection will, its authentication, it's at the authentication stage, it will fail. And the error code in that case indicates that it should then try to connect to the next network. So it's not, so what happens is if the CSG IDs don't match, but the device doesn't support, it will try and connect anyway. The connection will fail, and the UE then will say, okay, let me go try the next network that's broadcasting this CBRS SHNI. And it will keep doing that until it finds one where the network says, oh, I recognize your MC, you can connect. So that's the impact of it. So the authentication fail, the UE won't be able to access that network, it won't be able to access the wrong network. It'll say, okay, my connection was rejected, I will move on to the next. Let's see. So how would the UE access the network? So without that CSG ID mechanism in place, all that happens, again, it will try, if it tries to connect to the wrong network, one that's broadcasting the shared HNI, but it's not an authorized user of it. The CSG IDs don't match, but it doesn't know it because it doesn't support it. It will try and connect and it will fail. It'll move on to the next one. It'll keep doing that, but if once it connects to a network that connects to the right network where the CSG IDs do match, it is the right network and is a known device, the authentication will be successful and it will connect normally. So basically it will, from the user equipment device, from the UE perspective, it connects normally when it's the appropriate network. So there is no additional element that comes up. We got lucky essentially with the CSG ID mechanism. It solves our problem, but when devices don't support it, the failure mode actually is not that bad. It's just the user device will attempt to connect to any network it sees that's broadcasting the CBRS SHNI, and then when it fails, because it's connecting to a network that doesn't recognize it, it just tries the next one and the next one and the next one until it gets to the one where the network says, oh yeah, I know you, you're an MC that I've offered, that I recognize, and will let the device connect. It's not ideal by any means, but since there can only be at most 15 networks operating in the CBRS band, each on a 10 megahertz channel, it can result in a network acquisition time that's increased, and it can end up being a couple of minutes. But in general, it's not that bad of a fallback condition. We have some more questions here. I know we're running a little long here. Let's see, are we mandating that device manufacturers support the NID for 5G? No, I don't know if that the NID mechanism in release 16 is mandatory, but I believe they're implementing it. If they're not, if they end up not implementing it, we'll have to address this. But my understanding is that they are, but I don't know if we formally mandate that. I will have to check if we are mandating the SNPN ID. It is an integral component if you support standalone non-public networks. So if the device supports SNPN, it has to support that. But I don't recall off the top of my head if we are mandating that you support the SNPN. So if CSG is not supported, but the PLM and ID and MC are all legit, the network should still recognize the UE and allow it to connect. Yes, that's basically it. Even if the CSG ID is not supported, as long as this MC is good and it's a known MC, the network will allow the device to connect. That's the fallback, and that's how the system. That's why we are able to function even if we don't have CSG ID support, because the MC is recognized by the appropriate network. Do existing dual SIM CBRS devices support priority mechanism for PLM selection to identify and attach to each CBRS network while roaming in from macro to the island network within a sea of existing macro network? I don't believe we have formally defined, and I don't think 3GPP has formally defined what the selection mechanism is when you have multiple SIMs. And so there's no formally defined mechanism that says these are the conditions in which you will select your CBRS network island in the middle of a larger network. I do know that's one of the things that's being worked on by some of the MNOs, at least one of the MNOs that's doing field trials of roaming in and out of CBRS networks. That's one of the things they're working on, is how to do the network reselection. And that's something that's part of LTE, how it functions. Some of the parameters that can be sent to the device about network selection can be done there. But there is no formal mechanism, as I understand it, for dual SIM when you select that secondary SIM. When you switch back and forth, I think that's really up to the device maker, and it's something that they can set, be it user interface or some priority or mechanism. But I don't believe that's formally been defined. Is there any work in OnGo or 3GPP to make the CSG-ID mechanism more efficient in terms of signaling? I'm not aware of any efforts right now within the 3GPP about improving the CSG-ID mechanism or mandating support for it. It's up to ultimately the device makers whether or not they enable this within their devices in their software stacks. But I don't know of any development work in the 3GPP or in OnGo for that matter about making that more efficient from a signaling perspective. There is work on a geofencing stuff that's coming out in the next version. That's an ongoing effort, which will partially address some of this. But that is an entirely separate topic. And I will let the experts that can talk about the geofencing stuff speak to it. That will address some of these efficiency issues, but that's yet to be published, and that's in the final stages of development within our technical working group. Yeah, so somebody's noting, yeah, they've noticed that CSG is not certified on many devices. And again, my understanding is that the device makers implemented it, and tested it initially to make sure it worked, but they basically disabled it in their primary software builds. Does OnGo do device certifications with the OEMs to ensure these critical features are in place? There is ongoing efforts within the test and certification working group about adding these kinds of things to the OnGo device certification. But right now, we currently just certify the CBSDs, and we're looking at adding support for certification of other elements as well. And that's something that's being discussed within the test and certification group. And hopefully we will have some updates on that here soon. I think they're talking about doing like level 2 certification, and that will include some of these kinds of features, but it's a matter of prioritization within the alliance and the membership, which ones we start doing and when. I don't know if there are any formal plans for certifying the CSG-ID mechanism, but it's something we could do. Certainly, and it's something if the members want or the market needs, we can add that. But that's the test and certification guys. I will mention that the question was asked and put it on the discussions that maybe that's something we want to do, is like this add CSG-ID mechanism support is something we check, or in release 16, the SNPN. And there's lots of things being discussed as what we can do within the certification program, but I will pass that along. All right, I think I've covered all the questions here. If you have any other questions or I missed them, we'll go over the list at the end too on our side. But again, if you have any questions, you feel free to reach out to me. You can reach me at shni@ongoalliance.org, and you can order your identifiers from the OnGo Alliance and the MC Administrator at the following links, and we will be posting these slides shortly. But thank you very much. Sorry for running a little bit late. We got a lot of good questions. If you have any other questions, again, follow up. Again, thank you very much, and have a good day.